Hello everyone, thanks for joining us today for Designing for Azure Security and Data Integration webinar. So Shivam Sharma is our speaker for today. So just to give you a quick brief on his profile, Shivam is a cloud architect, trainer, speaker and founder at Tech Scalable. He is passionate about evolving technology and works on Azure, Google Cloud, machine learning and blockchain. Uh, He also comes with a lot of training and a consulting experience. He architects solutions on cloud as well as on premises using wide range of technologies. Over to you, Shiva.
Hey, hi everyone. So welcome for this session, and hopefully you have joined the previous sessions which we have done before. And this is another session in the same series which we are doing. And let me quickly walk you through the agenda for the day. And we'll be talking about Azure Data Factory, Synapse. We'll talk about Azure Managed Identities, what are key vaults, what is Azure policy, blueprints. We'll have some very interesting demos, and we will also check out the solution architect certification path which is there, and then we'll have a Q&A round. So questions and answers you can always ask. I am looking at the chat window, and if you have any question at any point in time, you can put in the chat window, or you can wait for the end of the session also, and I will try to take all your questions during the session, or I will take the questions on the way as well, right? And then after that, we'll have one quick quiz. So in the end of the session, the quiz is very important, and based on the winners of the quiz, we will be announcing, we will be giving some free Azure vouchers, and with those free Azure vouchers, you can give your certification. So if you are planning any certification, maybe you are planning 303, 304, we'll talk about those certifications, what's the meaning of that. And apart from that, if you're planning any other certification, we can give you the vouchers, right? So please wait for that quiz part and pay attention to the session. The answers will be during the session. We'll cover all the answers of the quiz, and do wait till the end, attempt it, and get the free vouchers as well. So let's get started, and we have 2 hours of session. So check this out. So we will be talking about, so today is about data integration, and whenever we do data integration, we also talk about security over there. Now security is you can say the core of any solution which we design. Maybe you are moving your data from on-premise to cloud, maybe you are moving your data from cloud to cloud, or maybe you are moving your data inside Azure cloud itself. Security is something which always comes into picture, and that is something which is core to the designing of the solutions. And if solution architecting is one of the goals which you have in mind, if that's what you are looking for, then you have to understand how to have secure data movement or secure integration of various solutions. So today we are focusing on the security part of Azure and on the data integration part of Azure. So we are mostly moving data around, and we'll talk about all the data movement technologies, storage technologies, where do you keep structured data, unstructured data, semi-structured data, and how do you visualize the data, how do we make the ELT pipelines, ETL pipelines. I have demos for you where we will be checking it in depth, right? So let's get started with it, and your questions, please put them in the chat window. And so have a look at the so in all the companies, so today data is very important. We don't throw data anymore. We have solutions like Data Lake, where we keep data which are like single master source of data, or the single source of truth of data as such, and we keep the data over there, and then we extract data from those single point of data storage locations, and then we process, transform, and we use those solutions in many part of the designing. Like you might be having data engineers in the company, or data scientists might be there, or we need to have some sort of descriptive analytics. So you need to do reporting on top of data. So for all the various bits and pieces, we need to have analytical systems in the company. Now, when we design these analytical systems, your data is not centralized only in the cloud platform. And most of the companies, when they move to cloud, they don't leave the footprint. They don't just move entirely to the cloud. They have some footprint on-premise also. And so if you have data on-premise, maybe your data might be in SAP systems, it might be in SQL servers, might be in Oracle, might be in some file shares, might be just lying around in a file share, you can say in FTP location somewhere, or it's possible that your data might be coming over stream. You might have IoT scenario or maybe event-driven scenario and data is coming as streams from the sensors around the globe and maybe from any applications where the users are creating some events. So for a lot of different type of scenarios, we have to create those solutions where we ingest data. So if you can check this out in Azure, when we talk about ingestion layer solutions, we have Data Factory is one of the solution which ingest data. We have Event Hub also, which also ingest data into Azure. If you're wondering what are these solutions, just hang in for 5 minutes, we'll cover them. Right, so as part of ingestion of data, we are collecting all the raw data which is coming from device, maybe any point of sale device is there, and all the data is getting collected, and then we do data processing on that. Then whatever data we have cleaned, we store that clean data. Now on that clean data, you might be doing data exploration. So it might be used for reporting, or maybe you are doing any predictive analytics on top of it. So then we have machine learning scenario in picture. So before I take you way more deeper, there are two things we have to talk about. That there are two systems. We have ETL and we have ELT, like that, right? ETL systems and ELT systems. So ELT, or you can say, let's cover the ETL first. So ETL is the traditional system where we have the extraction of data and transformation happens, and then we load the data after transformation. Now, one drawback of ETL system is that the transformation, it depends on the capacity of the server, which is where we are doing that transformation. And if we have huge volume of data or velocity of data, then at times it's not possible practically to transform data on the fly. So then as improvement or wherever complex processing comes into picture, we have ELT in picture, right? So for example, we extract data, we load data, and then we transform it. So we will be talking about Data Factory, and before I run you through the slide deck, I don't want to do any death by slides, so I'll take you to the whiteboard, and I have some of these architectures pre-created, and rest we'll create together. So have a look at this. Now, in any traditional system, you might have heard about OLTP and OLAP systems. Like OLTP are the transactional, or any system from where you're doing any transaction, maybe order processing, order placement, and relational databases are very popular OLTP solutions. And one of the most popular relational database is SQL. And in Azure, we'll call it Azure SQL. And when we talk about, and there is another type of systems called as analytical processing system. So as part of analytical processing systems, we have warehouses. So warehouses are the ones where you store, let's say, last 3 years of data, and on top of those last 3 years of data, you're doing any descriptive analytics. You are describing why the sales was high or why the sales was not high, or what can we do to make the sales high. So any type of description of why it happened can be done on top of OLAP. So in any traditional system, you have OLAP, OLTP, and requirements of reporting as such. So if you aspire to become an architect, or if you're already an architect right now and you are thinking of it's your job responsibility to create these solutions, then you also have to keep in mind that in today's world, after IoT becoming so popular years back, we have huge amount of data in picture. So data might be coming as streams, data might be coming from some on-premise location in batch mode. So when we talk about ingestion layer solutions in Azure, imagine this is where I have mobile applications and data is coming from here. So all the data need to be ingested in the cloud. And based on the velocity and the reporting requirement, you may want to create any hot path or maybe cold path over there. So this is where I'm saying, let's say I have Event Hub. So in Azure, we have one solution called as Event Hub, which is one of the real-time ingestion solution. And once we, and let's say you have huge amount of data lying on premise, I'm saying, let's say 170 terabytes. And now you want to move this data to the cloud platform, right? So this is part of batch analytics or batch mode transfer of data. So this is where today's topic will come into picture, Data Factory, ADF. So you move data into the cloud over there, and this is where you might have storage accounts in Azure Cloud. Now, those who are new to the cloud platform, in Azure, we have object storage called as storage account, and they store around the upper limit will be 500 terabytes of data, right? One of them can have 500 terabytes of data. So once the ingestion happens, maybe the ingestion is happening over stream, or maybe if the ingestion is in batch mode. In both the scenarios, you have to process your data. So you can see that data is coming through that on-premise location, or maybe you have kept the data in storage account. Now you're doing some processing on top of it. So as part of processing solutions in Azure, we have many. You can do processing. It depends on what's the time requirement. Like if we want to do reporting within 3 seconds, 4 seconds, or 5 seconds, or if we have any cold reporting requirement, we are looking for some sort of once in a day, once in a week type of report, or maybe report where you're doing something in a batch mode, maybe 2 hours, 3 hours. Then based on that, we can select the technologies where we can process data. So you can go for solutions such as, in Azure, we have solutions such as Stream Analytics. That's the name of the solution, right? It's not like that's the name of Azure Stream Analytics. And we have, you must be aware of Hadoop and Spark. So we have Hadoop based solutions, we have Spark based solutions. So these solutions are part of processing layer. And once you have processed your data, you also want to store the data somewhere. So for storage, we can again use storage accounts, which are object stores. You can use data lakes, and data lakes have no upper limit. In Azure, we don't have any upper limit of the data lake. So this is where I have data lake in picture. Or we can have Cosmos databases. Cosmos databases are globally distributed databases where we can have multi-write global, or maybe single write and multi-read type of scenarios. So storage solutions will be there. And or you may have to store your data in warehouse. So that's the warehouse over there. And the purpose might be for machine learning, or maybe for reporting, or maybe for any other process which is downstream. So in today's world, being an architect will require you to understand all the different parts of any data movement pipeline. How do we ingest data, process data, storage data? So the field is very big, and we have 2 hours with us. So we have a very set agenda for the day. And so what are we focusing on? We will be checking out how do you do the data integration, and how do we do the data integration should be secure as such. And we will try to learn Azure Data Factory, Key Vault, Synapse Analytics, policies, and blueprints, or anything as such which is related to security or the data integration point over there. So let's understand one scenario, and then we will start with it, right? So imagine you are the architect and you have to design some solution. Maybe the requirement is of reporting, or which the data analyst is looking for data on which he or she needs to do some reporting as such, want to describe the data. Or the requirement might be of any solution where predictive analytics needs to be done in future. So maybe the data needs to be provided to the data scientist, and you are supposed to create that solution. You need to provide them with data, and during the data, and when you provide them the data, you also have to select the correct technologies over there. You should understand the pros and cons of these technologies, and you should be able to understand let's say what to select in which scenario, which will be cost effective, what will be more secure, what options are there for security purpose. So this is the area we will be focusing on in this session, right? So we need to provide data to the data analyst or data scientist, and how we will do it, that's what we are focusing on. So check this out. And I have one demo which we will be doing for the session. And this is on a very high level, that's the architecture of the demo. And we will understand what are we doing, what are we thinking, how are we designing it, and parallelly, we will also do it. So first, let me walk you through the various technologies which are there, which are required for data integration, and what options are there. And once we have done it, we'll see the demo, right? So first, let's understand on a higher level, what are we doing? And then we'll go in more deeper, and we will do the demo along with it. So check this out. So as we were just talking about that, data might be available the data location might be on premises. You may have data on-prem, or data might be in any other cloud. Maybe it is Google Cloud Platform, or maybe the data is available in AWS, or maybe the data is there in Azure, in your Azure subscription, or maybe in any customer's Azure subscription. So data might be in OLTP systems, data might be in any other type of systems. So the data scientists and data analysts, they are looking for the data right now, and we have to provide them with some secure way of reaching to that data. And on the way, we'll do some transformation on the data, right? So the scenario is that data might be available in various type of locations. So first of all, we have to extract the data from those locations. So if we talk about ELT, in ELT, the first two, you can say E stands for extract and the L is a load part over there. So as part of data integration, you have to extract data from various locations. So imagine, let's say, on-prem, cloud, AWS, Azure. So this is where the extract part comes into picture. Extract. Now, when we create these data movement pipelines, the solution which we use is called as Data Factory. Data Factory, if you have worked with Oozie before, or if you have worked with SSIS, or if you have worked with Airflow, then Data Factory is similar to them. And if you have not seen those products, then today you will learn about Data Factory, and those products are similar to Data Factory then. So the first thing which we have to do is that data might be available in different locations, and we are looking for some way to extract the data. So what do? We go to Azure and we create this instance, or you can say we use this service, ADF, Azure Data Factory. Now, Data Factory is very interactive. There are a lot of it's a GUI based solution where you can drag and drop and you can create your pipelines. So in Data Factory, we have various type of activities which are available. What are activities? Like, they do one type of task. Like, we have copy activity, we have Python activity, we have serverless activities, we have variables. You can pass variables, you can insert any, you can drop emails to people on the pipeline during the pipeline execution, or you can integrate multiple different pipelines together. So activities are there. So for example, there is one type of activity which we will be using that is called as copy activity. So, and then we'll talk about other type of solutions which are there, but that's the first thing we are doing. We will be copying some data from, you can say, one of the location. And if you think it through, when you copy your data, it's always from some source to sink. Like, there is a source and there is a sink over there. So we copy the data from source into sink, right? So, okay. So what are those source locations? So one of them will become the source location, and the sink is where we will be using. In Azure, we have various type of locations where we can, which we can use for sink, and the one which we are going to use in this scenario will be data lake. So data lake, if you want to understand what is data lake, in big data world we have HDFS, the distributed storage for big data, and in Azure, data lake is compatible, or you can say 100% compatible with HDFS. It's not really HDFS, but it is compatible with HDFS. So whenever we have any big data scenario, you want to create Hadoop cluster or Spark cluster, the storage goes into data lake. And what is data lake, if you're wondering? Data lake is a generic theory concept. In the theoretical concept, it means that it's one location, it's a very giant location where all the data of the company will be stored, and various systems can read the data from there. Even if you lose your data in any other process, you can recreate your data from that single source of truth. So as part of the ELT pipeline which we are planning to deploy, we will extract data from other locations, and then once we have extracted the data, we are pushing that data into the sink location. So this is where that load comes into picture, right? So Data Factory contains extract, and that's happening from on-prem or cloud, and load goes into data lake over there, right? Now, so what are we going to do? We are using Azure SQL. So Azure SQL is one of the source location from where we are reading the data. So we are assuming that Azure SQL is the one so Azure SQL is the OLTP system where any process is right now doing the transaction. So the scenario which we are taking is that there are many taxi cabs, and the data is coming from these taxi cabs, right? And when you think about taxi cab, there will be various type of mobile applications or various endpoints will be there. The endpoints of the driver will have a different mobile application. The you can say the one who rides will also have different type of a different endpoint of the mobile application. So we have data which is coming from both of them, which is getting stored into the SQL, which is becoming like the OLTP system right now. So we will be creating two tables over there, trip data table, and we'll have another table called as trip fare table. So that's the source of data which we are taking in this scenario, right? We'll make that SQL very soon. Now, just FYI, in Azure, SQL can also be serverless. So we are creating that serverless SQL. So what is serverless SQL? Like when you create SQL solutions, you can make them in virtual machines. So as infrastructure of service, you can also create SQL solutions as part of platform as services. But there is a new offering called as serverless SQL. Now in serverless SQL, we have min-max and pausing mechanism. So if there is inactivity, the SQL automatically pause for that point in time. So that's what we will create. We will check that out practically, how that looks like. So Azure SQL will become the source of the data for us, and we definitely will be connecting to it. You see this red icon which we have. Now in Data Factory, there is another concept called as linked service. So see, when you read your data from maybe from you can say SQL, or if you want to write your data into any location, you need to connect to that. If I'm reading from AWS S3 bucket, I need some sort of access token from there from which I can read it. And if I'm reading from maybe GCP buckets, then also I need access mechanism to read the data from there. So we will be creating some linked services. The meaning of linked service is connection configuration, like how do we make the connection over there. So in terms of linked service, we will be using the SQL authentication username and password, but we are not hard coding the password anywhere. We will be using another secure method of communication, so which we will understand on the way. So as part of the demo, we will be creating SQL. We'll have some tables inside that, and then we will have some linked services, and then we will be doing the copy part of it. Like we will extract data, and data will be extracted and will be written into the data lake, which will become the sink for us. So from source into sink is what we are doing, right? That's the source, and this is the sink. So E and L of the data integration pipeline will get covered once we have seen that. So we'll go into the demo now. Rest of the diagram we will understand on the way. But there is something which is very important which you need to understand. That is called as integration runtime, IR. So integration runtime stands for, whenever we are moving data is, the resources are used in the backend to move the data around. Meaning when you read your data from any source into any sink, you need resources. Servers are there behind the scenes, and you need CPU, RAM will be there, IOPS will be utilized, network will be utilized, and any resource which is utilized at the backend to read your data is called as IR, integration runtime in Data Factory. So we will be creating one integration runtime, and when we will run this pipeline, right? You see this is the pipeline we are creating, which we'll talk about end to end. But once we run this pipeline, the real heavy lifting, or who really moves my data around, it's this IR which actually extract my data from here. This is extract, and this is the IR which loads. So what is Data Factory doing? Data Factory is where we orchestrate the solution, and the real heavy lifting is done by the integration runtime at the backend. What are those? These are servers which are doing that. And who's maintaining these servers? Now we have actually three type of IRs. So the one which we are going to use is Azure IR. Like Azure will maintain the servers at the backend, and using that we will extract and load the data. To make it more secure, we can also use self-hosted IR. There is another mechanism called as self-hosted IR. So when we read data from on-premises, we use that. Like if you are getting your data from on-prem, we create these servers on-premises and we install some agents over there, and then we are able to pull the data from on-prem. So more on that later on. For now, let's do this, what we have talked about. We'll create one data factory, right? Let's create one SQL, and we'll have these tables over there, and we will create the data lake, and we will do till the point we have talked about, like we will extract data and we will write over there. Once we have done it, we will do some transformation. So for transformation, we will go for data flow. We'll talk about it. What is the meaning of it? So this is transformation. Now, if you are planning to give the certification 303, 304, the questions around data integration will be there, and questions around security will be there. So if that is what you are planning, this one webinar will help you answer a lot of those questions which will come. So let me take you to my Azure portal, and we will create some things over there. Okay, now what I have done, I have so my Azure portal is here, and let me just that off. Okay, so the very first thing which we are doing is Azure SQL creation. So I just want to show you. So what I did to reduce time, I was deploying some of the resources. You can say some of them I have already deployed, but rest I will deploy in front of you, right? So let's start over here, and let me find my portal back. Okay. So now, as we know that in Azure, everything is organized in resource groups. So there is one resource group which I have created called as webinar resource group, or tech scalable webinar RG. And I have the backup with me in case something breaks in the demo. Then the backup is also there with the end-to-end solution. So what are we going to do? We need multiple things over there. We need one SQL, one data lake, we need data factory in picture, and then we need to configure the solution. So I am clicking on the add option on the top, and I have opened multiple tabs on the top, so I don't have to refresh the same page, and we can go back and forth in the tabs and do it parallelly, right? So what I'm doing, I'm creating the storage account first. So I'm creating the data lake first. So data lake is that unlimited upper limit. There is no upper limit in data lake. And how do you basically make data lake? So we will search for storage account over here, and once it loads, I'll just click on create. So what are we doing right now? We are creating this part where we have the sync location. That's what we are doing. Okay, so I'm giving this the name. I'm saying this is name needs to be in small letters. Let me put it like that. Tech scalable, let's say webinar ADLS, Azure Data Lake, you can say generation 2, like that, ADLS Gen 2. So this is my webinar. Let me put it like storage webinar. Okay, let me put it like that, ADLS over there. Which location? We have more than 60 locations now. We are going for East US. Why are we going for East US? Whenever we are creating any data integration pipeline, it's good that if your big amount of data is near to the location where you are syncing it, and it's near to the location where you are running those compute clusters. So we don't have to pay for the data, the egress traffic, and also we don't have to pay for the, it will be quicker if the big amount of data is moving in the same region. So we'll put everything in East US because of that. And I am not looking for any redundancy right now. Let it be the smallest one. So what are we doing? I'm clicking on this advanced section. Now remember this, if you want to make a data lake, you have to create storage account. Then you go to the advanced section, and then there you have to click on the data lake enabled like this. You see this, Azure Data Lake Gen 2 enable. So now this will not be a storage account, that will be a data lake. And what is data lake? This is compatible with HDFS, and there is no upper limit. So what have we done? We created the sync location. So this is what we created over here, the sync location where we will write the data. So what's the size limit? No size limit. And we will be creating one container over there. What is container? Container is like, you can say, collection of objects, like we have binary large objects, when you store data in these type of solutions, they are stored as objects. So we will create one staging container over there, and this is the one where we will be writing the data in the sync part once we have extracted from the source, right? So let's go back, and data lake is ready. We can click on go to resource, and you can see it's over here, right? We'll go to container, and this is where we are creating one container. What's the purpose of this container? When the data will be written, right, it will go there. When the data is loaded, it loads in that location. So let's give it staging container, right? Let's put it like that, staging container. And so access, we are not concerned about access right now. We don't want to make it public access, and we will keep it private access the way we keep this in production. So this location is where we will write the output, right? That's the output location. Let's create one data factory. So I'll click on create a resource, and data factory is that pipeline which we are creating. If you have worked with SSIS before, you will find this to be exactly similar to it. If you haven't worked with SSIS on premises, then this is something which is very interesting, so you can have a look at it. So I'm creating my data factory also in ESTS, and let's give it a name. So now I think it's all good. ADF, let's put it like that. Let's see if the name is available. Okay, so the name is it's globally available. Nobody took that name, and it got created. Now we can also, in production, one extra thing which we do is we always integrate with GitHub. Now I don't have any DevOps pipeline in picture right now. Neither are we focusing on DevOps today. And we had the session, you can say the previous webinar which we did was on DevOps. So in future we may be doing more MLOps, you can say webinars, where we will be doing integration of machine learning deployments with DevOps. So right now we are not doing that, at least not in this point in time. So we are saying get configuration later. Otherwise, we enable this get configuration. We have to provide our Azure DevOps project, and then we integrate with it, and then we create the release pipelines with Azure DevOps, right? So okay, so for networking right now I'm not going for that, but we will talk about this private endpoint very soon. That's part of the security consideration of when we do the you can say data integration, like how do you make it more secure. So remember that, we'll come back, we'll talk about it. For now we'll just create this data factory, and I'll just confirm the location. Okay, I think I didn't give the right location. So I want this to be in East US, and let me check that again. Okay, now looks good. Let's try. So what have we done? Like, what are we doing in this point in time? What did we create? We created this data factory where we have to design the solution. This part, the gray part which we are making on the top, that's what we are doing right now. And once we create that, we will be doing some activities over there inside it. But for now, that gray empty box is coming up. That service is there. Now let's talk about the SQL, right? Now check this out. So okay, now when you create the SQL databases, I am just going to, let me just confirm these existing ones. Where are they? Okay. Okay, notice this. So when you create the SQL solution, basically we give the database name over here. And now because Azure SQL is platform as service, there is no infrastructure over there. Infrastructure as service is not there. The VM at the backend is not there as such. So there is a new concept called as logical SQL server, which is more like a wrapper where all the databases are kept together. So we create this, we click on the server, and we create the logical SQL server over there, username and password accordingly. Now, very unique feature which is there in Azure SQL is serverless functionality. Like you see this serverless. This came out around 1.5 years back, and it was not there before it. And with serverless now, we can it's very cost effective. Now what happens? We provide the maximum resources which we want. Let's say like that, you see, 60 GB max, and let's say minimum I want 2.5 is the minimum right now, 7.5 GB minimum. So then based on the requirement, it will keep on going up and down. Auto inflation will happen. It will automatically scale up, scale down between that min and max. And then we have this pausing mechanism. Pausing mechanism means that if there is inactivity, so if the inactivity is there for minimum is 1 hour, and if we have inactivity for let's say 1 hour, then automatically the compute will be paused. So we'll keep on paying for the storage, but the compute will be paused. So now to create the SQL, it takes 2-3 minutes. So once what I have done, I created the serverless SQL. I made it the smallest one, and we don't have any heavy requirement right now. So I made it around something like this and kept it to 1 GB, and I already deployed it. So my SQL is ready over here, and the one which let me go to my resource group. I'll show it to you there. So this is the webinar RG where we are, this one, and if I click on it, that's the SQL which is ready. See, so this is the logical SQL server over here, text scalable webinar SQL server, and that's the SQL database. One database is there inside it. We actually are looking for some specific data. So we have around 50,000 observations with us, or 50,000 rows are there with us. So what are we doing? These 50,000 rows needs to be ingested or needs to be created in the SQL. So the way I have it over here, or the way we are doing it, is I have one backpack file with me. So I have one file, you can say .backpack, PSC over there, and this is one SQL database where we already have those two tables. So what I'm doing, I will be importing that backpack file, and by importing that, can say that file, I will be creating both my tables over there in SQL. Right, so you can also, so this is very good when you're doing any migration, but or you have to really create one front end from where we are doing the transactions in the database. So for now, we will be creating that data over there by importing the already existing backpack file. So when we do the migration to Azure, that step also comes into picture. So how do you import your SQL databases? We basically click on this option, see over here, import, and then we basically look for where it is available. So what I have done, I have already uploaded that backpack file in one of these storage accounts. So I don't have to upload it over internet. Yeah, oh, this is not that one. Let me quickly look for it. Yeah, this one, see. So we have that taxi-data.backpack. Now where is this in the diagram? This is not in the diagram, this is somewhere over here, right? So we are giving that location from where we are uploading it. So that location is that from where we are importing it. So why are we doing it? Because we need some data to work with. Otherwise, how we will check out the data integration part. So we are importing some data for our scenario or for our demo. So this is the one which we are importing right now, this one. So we'll select it, and now it is asking that how much resources do you want to give. So we'll give it, we'll go for serverless solution itself, the one which we just talked about. We are not looking for any very powerful database, so we'll say that okay, 6 GB RAM is good enough, and minimum can be 2.05. And if there is inactivity for maybe 1 hour, you can auto pause. And if you're wondering what's the biggest size of database which I can create, 100 terabytes, 100 TB like that. For now, we are okay with 1 GB also. And then it is looking for some password over there. So let's go for it. Let me just retype that. Okay. So data is getting imported. It will take some time for that import to happen, right? So now let's understand how are we planning to make it more secure. So in Azure, or let me have a quick revision of what we have done till now, then we'll go further, right? So there is one SQL which got created, and we are importing one database over there. In the logical SQL server, we are importing one database right now, and inside the database we will have two tables. We will have the trip data, and we'll have another table called as fare, which we want to ingest, and where we want to do any transformation. So the way we are thinking is that this SQL might be on premises, this SQL might be, this relational database might be in cloud, in GCP, or maybe in any other location like that. So we are pulling our data from that location. So once we have imported that data from there, now then we will be writing it into some location. Now there is one thing which I want to bring in. How do you make things secure? In Azure or in the world, we have one concept called as hardware security module. Now hardware security modules, HSMs, are if you look up in any of the search browser, you will find them to be like a small type of, you can say like a router box, like small box is there. Let me see if I can show you one picture of it. Check this out. So this is hardware security module over here. You see boxes like that, like this. So that is HSM, hardware security module. So on premises, when we have to secure any certificate or SSL certificate, or maybe any key can be encryption key, maybe any primary key, secondary key, on any password, then we keep that data inside HSM. HSM is very secure. It's even encrypted on the hardware level. So in Azure, we have one service which is built on top of HSM. That service is called as Key Vault, like that. We actually have two types of pricing in Key Vault. There is one pricing called as basic pricing, and the another one is called as standard pricing, like that. So, there are two pricing as such, basic and standard. And let's create one Key Vault. We'll check out the pricing on the way. So let's go back, and we need it. We are doing something with it. So let's do that parallelly. And this is the Key Vault which we are creating. And so now the purpose of Key Vault is that the security keys will be kept over there. In our scenario, we have SQL authentication, which we can keep at least over there. Like for SQL authentication, the username and password. And at runtime, Data Factory will pull that key from Key Vault and will execute that. So this is the text scalable. Oh, sorry, let me give it a proper name. Right. And let me just put webinar over there so I don't mix it up later on. Okay, so I think we have hit 24 limit, like that. Okay, this is great. Now check this out. So the two type of pricing which we have is the standard and the premium one. So let me update my diagram over here. That's what I was thinking about, that it is called as standard and the premium. And the difference between them is that standard is where things are software backed. Whenever you upload any key over there, it will be software backed, right? And in terms of premium, the key will be you can secured or will be stored in the hardware in HSM. So this is where we secure that. So two options are there. For now, we'll go for the standard one, and we will just say that please use it. The other one will be more secure, but you can say way expensive. Okay, so for now, we are saying that if you delete anything, any key from Key Vault, retain it for 90 days. This is more like a soft delete, or you can say like a recycle bin. Let me just confirm East US is selected, and we are in the correct resource group. Everything looks good. Let's create it. Okay, so what have we done? We also deployed another scenario. We deployed this Key Vault over here, this one, like this. And this Key Vault is right now empty. And now let's try to create the situation which we are doing. So we want to extract data from SQL into data lake. SQL might be in any location, cloud, on-prem, and we want to extract it using Data Factory. And the keys which we will be using for the connection configuration or connection strings will be stored in Key Vault, right? So there is a proper scenario which we are thinking of doing it. So let's get started. We don't have anything yet done. We only have deployed these high level scenarios. So let's go to Data Factory, let's drop this copy activity, and then we will start from there, right? Let's go back. So Data Factory is deployed, and Data Factory is a very GUI oriented solution. So if I open it up, it looks like it opens in a proper, it's going to open in the browser, and the browser is blocking some third-party cookies. That's fine. I think it should still load, and I will just make sure that my ad blocker is down. Okay, so that's how Data Factory looks on a higher level. So what are we doing? We are actually going inside the Data Factory, and we are clicking on the pipeline, and we are going to create one pipeline. So let's say the name we are giving, we can keep it as pipeline 1, right? Or we can also give any other name which comes to mind, maybe like integration pipeline or the webinar pipeline, or anything which is more suitable for the project which we are doing. Okay, so for now let's keep it pipeline 1, and what I'm doing, I'm just dropping my copy activity. You see this copy activity over there. Now when we copy data, we are always copying from some source into sink. See, source and sink, like that. So we'll pull from source and we'll write into sink location. That's one thing which we are doing, and then we'll continue over here. Now I just want to add the next step also, and don't worry about that, we'll come to it very soon. But this is now looking the way we were discussing in the diagram, and we'll talk about that transformation step which we are dropping over there. So for now we will copy some data, and once we have copied, we'll do the transformation using the other solution which we will learn about. Now there is one thing which I'm doing. You see this data flow debug, I'm just starting it. It actually takes around 15 minutes to create, so I'm starting it little ahead of time, so by the time we reach that step it should be ready. And what is that concept? We'll talk about that on the way once we reach there, right? So let's copy some data from source into sink. Let's go back to SQL and let's have a look at it. Was it able to finish the import of data which it was doing? Let's have a look at it. So the import is still going on. Okay. So in the meantime, what are we doing? We will let's do some connection configurations. So we'll create these linked services. You see this connection configuration here, this one, and one configuration for the sync purpose, that part. So let's do some connection configuration. In the meantime, the data is getting imported. So I'll go back to my Data Factory, which is here, and I'll go to the manage option, and I will just click on let's say new, and I'm looking for my source and sink. So check this out. We can read data from Amazon Redshift, Amazon S3 bucket, storage accounts, Cosmos database. We will be going for SQL, but you can see that we have so many other things where we can read the data from. So Synapse, Cassandra, Drill, Dynamic 365 on-premises, GitHub, GCP, S3, you can say cloud buckets, HDFS, and so on and so forth, right? So for now, we will just come back and we will search for SQL, and we are looking for Azure SQL, like that. Let's click on it and let's give it a name we can remember. So this is going to be, you can say, SQL database. We will name it like that. Now we have to connect to it. Like there's supposed to be a configuration which needs to be done, and it's asking for the database name. Let's quickly see, is this still finished? Okay, not yet. So what are we going to do? Let's do the other integration. In the meantime, the first one is not yet done. So I will simply make the other connection first, and let's give a little more time to SQL to import that, and we'll go for data lake. So data lake generation 2, like that, and we are just clicking on it, and we'll say that okay, this is the ADLS generation 2. Why do we call this ADLS generation 2? Because there was one solution called as Gen 1, which is now about to be deprecated. We don't create it anymore, and we are thinking about authentication method, like how do we want to authenticate. So we have to first go for at least the subscription, like which storage are we thinking of. So the storage which we have deployed is that one, text scalable webinar ADLS. So in the diagram, where have we reached? We are doing the connection to this data lake from the point of view of the diagram, right? We are just making this connection over there. So I will go for storage account, and now if you can, let's just wait for it. Okay, let me test it out if it is working out or not. Okay, great. So one connection done. Let's just save it. And database is still getting imported. So one thing which I'll do, I will go ahead with the connection with my backup SQL, which I already have, where the data is already existing. I think that will take maybe 5 more minutes. So I already have one backup SQL, and I'm gonna use that. So we'll give it the same name, like this is SQL database over there. And then are we looking for, let's say, what's the server name? So we'll go for the backup server which we have, the one which already exists. And I'll go for my backup SQL. And now check this out. So for now, we are going ahead with the configuration, but we will come back. We will talk about that key vault. We can even change that, right? We'll come back. We'll do it. Let's at least go ahead for now. So I'm connecting to my SQL. I just want to also check whether it connects or not. So we are trying it out. Like, does it talks to SQL or not? And let's wait for it. Okay, that seems to be a long time. And I will just give my password again. And let me try the password. If it doesn't connect, we'll give it this new password. So let's see. Let's have a look at that SQL in the meantime. Let me just have a look at it. Let's go to the resource group. Just want to have a look at it. So the SQL is basically connected. That's great. Let's go next. And okay, so connections are being created. So we haven't done anything yet, but we are able to create the connections, like from SQL into, and second data lake is being connected to. Like the configuration part is right. So let's do that copy activity. I'll go back to my pipeline and I'll go to my copy activity. I'll create that source. So I will say new. I want to read my data, which is there in SQL, and I'll say continue. And once I want to read my, let's say, trip data, CSV. So we'll name it something. We have one table over there called as trip table, like that. And we will select the same connection which we have, SQL DB, and we will load the table which I will confirm. Let's see. Okay, so doesn't seems to be loading. That is great. So hang in for a second. Let me quickly check it out. So let's go back to the connection. Let's click on it. Let's have a look at it. Okay. Now I think that database is not the correct one which I connected to. So let me connect again. Yeah, I feel that name is taxi database. So you can see how do you rechange the configuration. I'll just go to the other one. We'll give the same name, and we will just give the, let's say, backup SQL server and taxi data. I think that's the one from where the data is available. I was connected to the wrong database. So now it is correct. And let's go for the password and we'll go for the test part. Okay, so let's wait for that connection to be successful. Okay, let's wait for it. Okay, in the meantime, what are we doing? We are doing the first step in the copy in the data factory, the copy part over there. And we are creating the connections right now from to SQL, and we will pull the data from there into data lake, right? That's what we are doing in extract and load in ELT pipeline, the first two part over there. So let's check it out. Okay, so let me put the password one more time. I think the password, maybe let me try the password again. Yeah, works like a second time is always the charm, right? So second time it always works. So that's the SQL which is now connected to, and let's go back and now let's use it. So the data factory part is very you can say small and interesting. So we'll say that okay, we want to read the data from here. So SQL, and the data which we are reading is called as trip data CSV, and we are going for the same connection, and we have a table there called as trip data, and we will just add it. So this is the source of the data which we are going for, right? And in the sync we'll say sync, let's say new, and sync will be data lake. So let's select it, generation 2, continue. Which format do we want to write that into? In big data we have all these. We have Parquet is one of the go-to formats for Spark, and we have ORC, JSON, Avro, binary. For now we'll go for CSV. And so when you are writing the output into it, like when you write the output into the sync location, do you want to give it any name? So we are saying that okay, let's give it the same name, trip data CSV, and already exists. Okay, so let's say this is the sync part. Oh, sorry. So let's put underscore, and now ADLS Gen 2 is what we are connecting. The first row will be header, and let's say for now we'll say none. What's the schema of the structure? We'll say none for now. We already created that staging folder. We'll go for it. We'll select that, and that location we'll just say okay for now. Okay, so the copy part got created, and how can we check it out? Like, does it even run, or and so on and so forth? So we'll just check it out. So to check it out, I am just going to put one breakpoint here, and you can see this is the debug part, right? So we will debug the first part of the demo, and we have put this you can say the breakpoint, and now I clicked on the debug flow. So the debug flow will run, will start executing very soon, and let's wait for it. I will just go to my monitoring section and have a look at it. Okay, it should show here very soon. Okay, oh, it already succeeded. It was so the data is we only have 50,000 observations, so that's not very big. So it already got succeeded. So how do you how can we come to know that where is it? We can go to the sync location. We can have a look at it. So for now, if I go to my data lake, and this is my data lake. So in the sync container, we should have the data. So if I go to containers, and if I click on staging, my file should be here. You see this trip.txt file. This got created. So it means that my activity is running fine for now, and Let's do the next part, right? So as a quick revision, we were able to extract data from SQL and we were able to write in the staging location. Now we want to do any data transformation on top of it. So whenever you do the data transformation, you have multiple options in Data Factory to do that. One will be that we can go for any Spark cluster. We can create Databricks Spark cluster and we can do the transformation there. We can also create Hadoop cluster and we can do the transformation over there. Or we can also do the transformation with, let's say, Azure functions, which are serverless. For now, we are using Dataflow. What is Dataflow? Dataflow is one of the new offering, very excited offering in Data Factory, where transformation can be done. This data flow is backed by Spark, meaning whenever we run anything, it runs into Spark, but the data flow is GUI oriented. So what are we going to do? We will make one data flow, we'll open it up, and there we are going to do some transformation on the data. So the transformation which we are planning will be that we will pull the trip data, which we already have in the sink now, right? It will have around 14 columns over there. We will pull the trip fare also, around 11 columns are there. We will do inner join with it and we will have around 25 columns created because of it. Then we are doing some aggregation on top of it. So aggregation is where we will be doing some bucketing. Group by statement is very similar to how we do the partitioning in SQL. So that type of statement we'll run. And then we'll create some new columns, right? Some new columns will get created. And then the output of that we are going to write in the sink location. So we'll have one sink created as well. And the sink which we are creating is OLAP. So we are going for Azure Synapse. Azure Synapse is Azure SQL Warehouse. So this is the OLAP system which we are going for. So because the OLAP system takes around 10 minutes to create, so we will trigger the sink creation, and then we will come back and we'll go to the data flow. We'll design this over there, and once we will execute it, let's say we will run it, it will run, all this GUI will convert into one Spark code, and at the back end they will have Spark clusters created, and they will run the entire transformation on top of it. So the transformation will happen and the output will go in the sink location, like that. So the first thing which we are doing is we are creating that sink location, Synapse, and we want to do that ahead of time because it takes around 10 minutes to create. So by the time we will reach it, we will have it ready. Okay, so let's go and quickly create that Synapse before we can carry on. So how do you do it? We are looking for dedicated. Now Azure Synapse Analytics is not exactly one solution. Azure Synapse Analytics, it contains multiple parts over there. Like we have Synapse pipelines, we have Synapse warehouse, what we are creating right now, and we have the Spark concept over there. For now, we are just creating the warehouse. So I'm going for dedicated SQL pool, which is that's what I'm creating, the warehouse right now. And okay, so let me check it out. Text scalable, let's say data warehouse, like that. And just to identify, let me put the webinar also there. And it's automatically selecting the server, logical server which we previously created. We will keep it same. We'll keep that one over there, and we are just reducing the compute power which is there given to Synapse. So what is this compute which I just scaled down? Now, let me just click on create first, then I'll tell you more about it. Okay, so now Synapse, if we look at it internally, Synapse is, we call Synapse massive parallel processing system. So the structure of Synapse is like that. So we have control node inside Synapse, and the query hits the control node, and then we have compute layer. So compute clusters are there, like that. How many compute clusters can be there? 1 to 60. So right now I scaled it down to literally 1. That's what you saw me do. If we go to the maximum setting, they will have 60 compute clusters, or 60 compute nodes will be there. And then apart from this, we also have the data layer. Now data layer will have 60 distributions. So over here. So compute can be 1 to 60. Data is always having 60 distributions in Synapse. So when you write your data, it actually is distributed and it's written into multiple storage locations at the backend. So, and when you run any SQL query with it, right? So if I run any SQL query with it, the control node will break the query into smaller pieces. Imagine 60 smaller queries. Those queries will run in the compute nodes parallelly, and we will get the massive parallel processing will happen, and you will be able to cater huge transformations or huge data, you can say any data cube creation, or you will be able to cater a huge amount of data from all these nodes. So this is the back end of Synapse. That's how it looks like. So for now, we have just triggered it. Okay, so what are we doing? This part has been triggered. Now we will be, it will get created in next 10 minutes. So we will go back to Data Factory. We will check out the transformation which we are doing. And by the end of it, we will be writing the data in the Synapse location, right? That's the output location where it goes, the output of it. So let's go back and finish it. Let me quickly find the Azure portal. And the Synapse is in progress. See, it's still getting created. It will take around maybe 5 more minutes. So let's go to data flow, and I will click on setting. I'll say I want a new one. So new, and I will just say I'll close all these pop-ups and we will zoom in, right? So it is saying that add your data source, right? So what are we planning? We have that one data which we already pulled, and that data which we have pulled before is called as trip data. So now how is data flow getting its data? So the data which was in the staging location, that is the input now. So the input is over here. So data will be read from the staging location, and then the transformation will happen on top of it. So this step happens at the back end, right? So the data in the sink is now the source of the next step. So now the transformation will happen on the data. So we have to select the trip data, and then after trip data, we will also go for the other one. And so that we don't get confused, we'll just name it properly, right? So I'm just changing the name over here, and I'll call it trip data CSV. Let me say like this. So the data set should already show. That's the name which I want to go for. This one, trip data, which is in my sync location. Now it is asking that do I want, okay, so how do I show you how it loads the data? There is no column getting loaded right now. Let me quickly fix that. And I should simply go back to my trip data CSV, and I should import the schema, which I will just show you what do I mean by that. And I'm going to the sync location. I'll say schema. Please pull the column. You can say, okay, so let me quickly check that out. So, okay. And now is it letting us import from it? Yeah, connection store. So the column names will be pulled. You see this? The columns names were missing there. So now we'll go back and we will see the 14 columns are now popping up. That's okay. Let's add another data source, and this time we are adding the other one, right? So before I add the other one, how do you look at the data? So you remember the data, the debug cluster which we created. So if I click on this data preview and click on refresh, whatever we have done in the GUI will be converted into some sort of Spark program, and that will run on the debug cluster. So you will be able to see step by step whatever we are performing. And then finally, when we will execute it in the end, it will do the entire transformation in the pipeline. So let's wait for it to preview. Let me quickly check for any questions in the meantime. Okay, so now you can see that we have, so you can say the license, vendor ID, rate code. Let me zoom in. So that's the data which is getting pulled. A lot of null values are there. Date, time, drop, location. So the data is about the taxi. It's called as New York taxi, yellow taxi cab data. So this data set is real, and where we have two type of data, like the data coming from the of the trip, like what was the pickup location, what was the drop location, how many passengers were there, how much tip did they paid to the driver, uh, when the driver picked them up, and where they dropped it. So that type of data is what we have right now, and we are just looking some basic transformation. We are just doing some basic transformation on that data. Okay. Now what we are planning is that we want to merge data together. We want to just check out how data factory looks and feels like. So we want to do some merging of the data. So first thing which I'm doing is I just want to name it differently, so I will be able to remember it later on. And we don't have the other table. Let's pull the other table, and the other table is actually in the same SQL which we have previously pulled it from. So let's quickly pull the other table. So this table is fare table data set. Let me put it like that, data set, and same database, but we are pulling the other table, fare table, like that. And let's say okay, and let's see. Okay, so 11 columns are there. We can see that 11 columns are coming over here, and we have 14 columns. So as part of transformation, a lot of times you have to do sort of joins over there. So to do that joins, we are looking for you can click on this plus icon over here, and you can say join, and then what type of join are you looking for? You can see full outer join, inner join, left outer join, right outer join, or any custom join which you want. So we are going for left, you can say inner. We are looking for inner join right now, and we will go for we have to select some columns which will be common, based on which we can join both the tables. So let's look for some columns over there, and I will just refer to the column names from my notes. So because there are so many columns over there, 25 to remember, and let me just quickly confirm them. Okay, so the common columns are medallion. Let's go for it, and it's not loading it properly right now. Let me see. Okay, now please get selected. Okay, now it will show medallion. First one, we are looking for the license plate. So both the tables have common columns based on which we'll do the join. So like that. And then we are looking for vendor ID. Let's type it down. Vendor ID here, vendor ID there. So, and then the last one, we are looking for the pickup date time, and one here. Oh, sorry, I clicked on that. Let me close it. So you can also give any expressions as such, and it can also dynamically pick up things for you. So right now we are going for pickup date, like that. So what are we doing? Where are we in the diagram? We are doing the inner join right now. We have 14 columns with us, and the other table is having 11 columns, and we are merging all those columns together, and we are creating the final table. The number of columns will be 25 over there. So that's what we are doing right now. And let's go back and check out the data preview. What happened? Let's refresh, zoom out. Let's see, it's showing 25. Let's load some data, and if there are some null values, then we will take care of it. Or so in the meantime, it shows that. Let's have a quick revision. So we were able to extract data from the source. This demo is very complicated, right? But I hope you're able to follow me over here. So we are able to extract from the source. It's already in the sink. Now we are doing transformation on top of it, and based on transformation, we are using the two tables which we have, and we'll create new data set in the sink. That data set will be available downstream for further for the, you can say, processes as such. So you may have any reporting and data analyst doing any reporting on top of it, or data scientist using for this for AIML purpose. And now the best thing about Data Factory is that you can schedule it. It can run automatically. So in future, when we have more data, it will happen. You can say I can schedule it to for every week, maybe every day, once in 7 days. Okay, so it is saying that there are high number of null values, so we have missing values, and the sampling which we have done is very less, so increase the sample size. That's great. So basically what it's saying that in the 100 so we have 50,000 observations right now, and we are sampling around you can say 1,000 out of it. So they are saying that in 1,000 there is very less number of columns, a lot of null values are there, so increase the sample size, so at least we can have more data. So I'm just pulling 10,000 now, so I think that should resolve that problem. And let's refresh now. Okay, in the meantime, this it shows us some preview of the data over 10,000 observations from both the tables. We are going, the next thing we are going is we will aggregate. Now in aggregation we will be using, so what what we want to understand is that based on the payment type, like payment type can be how are you paying for it, like you are using some sort of maybe card system, you have credit card, debit cards, or maybe you have any type of application through which you are doing the payments. So based on the payment types, we will group by payment type. Now group by statement will be exactly similar to how we do partitioning in SQL, like we partition, right? So, or how do we do partitioning in Cosmos database? So it will create some partitions at the backend, and then in that partition we will be just based on the payment type, we will say, okay, take the average of this payment type and take the average of the distance. So based on the distance, what's the average payment which is there, and secondly, what type of payment was payment option was used to you can say to do that. That's what we are aggregating, and finally we will converge on that. Let's go back to Data Factory. Let's check out now. Okay, yeah. So we can see that now we can see the data over there. So 25 columns are there, and we can confirm that from this option. And now let's just go into the aggregation. So what we are doing right now in the screen, this is called as data flow, where we can design the transformation pipelines with GUI. This is one new addition, and before this the only way to do the transformations were by using the big data cluster, by using any Python activity or notebook activity over there in Spark or maybe in Hadoop, and then sort of orchestrating it. Now with data flow we have the equivalent of that with GUI. Okay, so what I'm doing, I'm just saying, let me just name it something. So let's say I want this to be called as aggregate by payment type, and then I have to group it. So incoming stream is join 1. We didn't name it, so it's already join 1. So it's already getting selected by default. What happens if I change it, right? If I change it something like that, see, it will change in my diagram. So it's a total different you can say logic which we are going for. Let's change it back to join 1. Okay, now how do we want to do the group by? So as we were thinking that we want to check out we want to check out the payment based on the type of payment which was done. So we will just drop this you can say group by payments and create new columns for me now, right? So I want some new columns to be created, so we will name these columns, and let me just quickly name them. So average, we are getting 2 new columns, average fare, and now what expression are we looking to build that? So we are saying that take the whatever the total amount which was paid by the customer, just take the total amount, put the average, and show that value to us. So convert to integer. All the data types are string right now. To convert to integer, otherwise we will not be able to run the mathematical operation on top of it. So convert to integer and find me the average of the total amount. So it will tell us like observation by you can say based on payment type, what was and based on the distance, what type of payment was done and how much is the average value of it. So this is one thing which we are doing here, and let me just click on it again. Let me confirm it. So I think I have skipped one bracket over there. Let me click on it again, and let me put that bracket as such. I can see two of them are opening and one of them was closing. So now it looks good. That should not come anymore. Great. Now another column which we are creating will be like the average payment was done on how much average distance. So we are going to put another column, and this one we will call as, let me put the name, total. I'll just refer to my notes over there, so I don't name it something else. Distance. That's great. And I have the expression copied with me. So we are just converting everything into integer and do the sum of the trip distance. So new columns will be created in this particular step. And how can we check it out? We can simply click on refresh and let's wait for it. So payment type, different payment modes, different type of cards will be there, and then how much. Okay, so we can see for now CSH and CRD. These are payment methods, and what was the average fare, and what was how much the distance is, how much average distance was there, and based on that how much total trip distance, and then what's the average fare based on that. And the value looks very big, so let's just carry on for now. So now what I'm doing, so what have we done? We were able to do the transformation with the GUI. Using this type of integration method, you can create maybe 200 step pipelines over there, and then once you have done it, you can write them in the sync locations. So the sync locations can be any. For now we will go for Synapse. So sync, and I'll just zoom in over there, and I'm saying that this is my sync location, which is SQL data warehouse sync, like that. And we don't have that sync location created yet. Let's go back and confirm if the sync is ready or not. So let's go back and check it out, because the last time we clicked on the Synapse, it was getting created. It was not done. But if I go back and check it out, you will be able to see this. You see this? The different icon which is there, text scalable data warehouse, dedicated SQL pool. So it got created, and now we basically want to connect to it. Now there is one thing which I will do. I will simply whitelist. I'll go to the firewall setting. I will whitelist the data factory. Now for now I am whitelisting like this, and to make it more secure, we can use the virtual network integration which is supported, and by which we will be able to securely connect to data warehouse. So let's go back and check it out whether can we, let's say, it connects. Okay, Synapse, and let's go back to link services. We haven't done any, and this is where we are saying that we want to connect to the SQL data warehouse, and let's say linked service. So it's part of the subscription, and the server name is the webinar SQL server. Let's load the data warehouse, text scalable data warehouse webinar, and we'll go for the for now the less secure hard-coded authentication, and we will talk about the Key Vault integration over there, and I will show you that part as well. Let me quickly check it out. Okay, great. So this got connected, and now whenever we write into Synapse, we have various type of table distribution modes over there. Now it's not we won't be able to cover about all the table distribution modes right now, but we have round robin table distribution mode, we have hash distribution modes and replicated distribution modes. So based on requirements, different type of tables can be created. So for now I'm just saying create a new table and go for the default schema over there, and As name of this table, we can say, let's say, aggregated taxi data as name of the table. And we will zoom out and we'll say okay. So after transformation, the data goes into sync location, right? That will become like the source of any other data analyst or maybe any other data scientist who want to pick it up from there. And if we want, we can really embed the ML pipeline also as part of this data pipeline. And let's just quickly have a look at the settings which we have done. So we'll say allow insert, and please make the table, in case we run it 2 times, please make it again. It is recommended that we do staging. Staging means that when you write into Synapse, write somewhere else and then load into Synapse. That's called a staging type of loading into Synapse. Right now we are just unticking it. It's not the main focus. And let's have a look at the data preview. If it is running fine, we'll trigger it. So we are waiting for that, this full logic to show us some output over here. Okay, so things seems to be working fine. Now, how do we, okay, let's go back and we want to just check it out. So let's validate all the steps. Like if we have skipped anything in the validation, it will throw the error. And I just want to publish all my steps as well, right? All these steps are getting published right now. And okay, so let's try it out. So this time we will debug till the end, and I'm just clicking over here, and there is one thing which comes to my mind. Let me quickly check out the sync location, because to get the schema I gave the file name over there, so that may, okay, tripdata.txt. Okay, so for now we are giving the same file name. If it throws any error, we'll come back, we'll change it. I think it may do that. For now, let's try it out. So debug, and now 2 steps are supposed to run, step 1 and step 2. Okay, so let's wait for it. And to check it out, we can go to the monitoring section and we can have a look over here. It should refresh and it should show us the new trigger. Not yet. So let's wait for it. Let's give it a couple of more seconds. Yeah, okay, queued. Showing. Okay, step 1 finished. Step 2 in progress. Let's wait for it. So how do you troubleshoot when things go wrong? You click on this monitor section, and here in the monitoring section, basically, so there is no error for this point in time. But if there is any error, in the error over here, you will see one icon, and you can click and you can learn more about what type of error came over there and what really happened. Right? That's one thing which comes to my mind, and let's see if I can show you that or not. And apart from that, we also can inspect in more depth, like what steps are going on. So you see this option is there, inspect. If we click on it, it will show us like step by step what is going on. So everything is queued for this point in time, and let's see why it is queued. So this pipeline will take some time to run, and in the meantime, let's see. Okay, that was a data import which we were doing previously, which we didn't finish with. Let me show you how does it look like once it is done, and we'll go back to the main one which we are doing right now. Let's go back to the main one. Let's see. Still going on. So that takes some time to do it. So let me show you how much time did it took last time. So this is the same pipeline which I have given with slightly you can say better names, because right, proper names. And let's check out the monitoring section. How much time will it take? Based on that, we can think it through. Should we wait for it? So triggered run. Oh yeah, sorry, this is the one. It was there. It loads in some seconds. Let me go back. Succeeded. Okay. And let's go to it. And basically it is supposed to take 50 seconds. That's pretty nominal. So let's go back and check it. So that's the successful run, right? So where both the steps were previously finished running, and 1 minute 35 seconds. Okay, that's also good. So the run is finished. And if you want to have a look at the steps which we have done, like how many rows were written and so on and so forth. So initially they were 50,000 around, you can say 49999 rows were there, which we started with. And then finally, by the end of all the transformations, you can say 3 columns are there, 1, 2, 3, and total columns are 3 which were written, and all these are all the transformed data. And the process happened in around 11 seconds. And then there is skewness also in the data, which is totally okay, which now the data scientist needs to handle, or like this. And this is how we are integrating the entire thing. Now, how do we make it more secure? So let's have a quick revision of what have we done. Then I'll tell you how do we make it more secure. And this is like the data integration which we have done right now. This is with the minimum security as such. But now let's go in more depth over there. So quick revision. We got the data from the source. Source can be on-prem, can be in cloud, can be in Azure also, in your Azure portal, or maybe in your customer's account. So from this sync, we did some connection configuration so that those link, the username and password is called as linked service. That's one thing. In the data factory, we created 2-step pipeline, copy pipeline and data flow. What is data flow? Now we have seen it work. Data flow is transformation, and it does the transformation by designing the pipeline and executing in the Spark at the backend. And the sync location that we went for is ADLS. ADLS is data lake, and which we are using for loading the data. So in the ELT pipeline, that is E and L, right? ELT. So E and L happened here. This is E, and that's the L part, extract and load on top of it. How do we do the transformation? The transformation can be done in many methods. We can use Databricks to do transformation. Databricks is from Databricks company, and they have one of the very best Spark solution. So we can go for Databricks transformation. We can also go for Hadoop based transformation. We can also go for data flow transformation. So for now we have done data flow transformation, and in data flow transformation we design the solution first, right? We can also preview the solution step by step, and to do the preview we can use debug cluster. So that's the cluster which I created in the starting, because it takes some time to generate. Whenever you run it, it runs in a debug cluster, right over there. So the GUI is converted into Spark context, and the Spark runs in the debug cluster, and which creates automatically on demand. And if we do not debug, if we execute in production, then it creates equivalent cluster, and it triggers over there, everything runs, and then the cluster is cleaned automatically. So on demand creation of Spark and then execution of the steps. So pretty useful. You can design your solutions. We did some inner join, little aggregation of data, and then we wrote in the sync as such. And now this sync is available for others to read from. And the for ML purpose we can also read it, for analytical purpose we can also read it, for descriptive analytics we can also read it. And what is that sync location? That sync is actually Azure Synapse, which is called as MPP, massive parallel processing. And this MPP system, it internally contains control node, and there will be a concept called as compute nodes. So computes are 1 to 60, scalable, and the storage nodes are always 60 distributions are there. So Synapse is something which stores structured data, like you will be able to run queries on top of it later on. So I can work with so what have we done? Now Synapse is a very big solution. We have only created the data warehouse over there. There are more options as well. Like you can create Synapse pipelines. You can create which are equal to ADF pipelines. You can also create other Spark cluster which are equal to the one which we have done. And data will be distributed. And when you run the queries, the control node break the query into smaller pieces that the query runs against multiple nodes. And we are able to cater huge number of read requests from these distributed locations. Right. Now, how do you make it more secure? Right. Now, whenever the security, if we think it through, there were some of the loopholes which we have seen in the till now. One loophole is that we were able to hard code, like it was mandatory for the engineer to write the SQL. You can say in the data factory pipeline, we were writing that SQL username and password, right? And the connection was getting established. Do we have any better approach than that? This is where Key Vault integration comes into picture. So what I'm showing you now is, I'll go to my Key Vault. Right. I will. Before that, I have to show you some extra things as well. But finally, we'll go to Key Vault. In Key Vault, we will create one secret, right over there, secret, and the password which we were hard coding over there, we will write in the secret. So, right. So the cybersecurity team or any other team who's not the cybersecurity team, maybe any or you can say anyone who's maintaining the Active Directory can also maintain Key Vault, or maybe the security team will take care of the Key Vault concept over there. And the secret needs to be created and kept over there once, and then we can pull it. So let's see that process. How do we do it? So to do the integration of Data Factory with Key Vault, it will take us some steps. So let's go back to the Data Factory first, and I will just try to click on it, and let me see if it is okay. Great. Oh, sorry, it was already clicked on. It was already the focus was already on it. So now I don't want to hard code the source password the way I did it earlier. I want to go for a better approach. So I will just click on edit, and I don't want to hard code it anymore. I want to use Key Vault, and we already have one Key Vault which exists, but we haven't done any integration with it. So let's call this Key Vault for the webinar. And yeah, oh sorry, let's remove that. Okay, now text scalable Key Vault like that. Now what is this managed identity? You see this option getting popped up over here. I'll just click on create. I think let me explain that first. We have to do some more steps. Now the managed identity means that what will happen at the back end, that's Active Directory. This is Azure AD over here, and in Azure Active Directory, that's basically IAM like this. So what happens if I do the integration which I have done? They will create some token endpoints for me over there. So one special token endpoint will be created, and basically what I have to do is, this token endpoint is the one which is associated with my Data Factory in this point in time. So this will get associated with it. Let me put it like that. The association will happen, and this is what we have to give rights on. So we will go and we will give it get permission. That okay, Data Factory, you can get the secret from Key Vault using that managed identity which we have created, which is more like a token endpoint over there. So this is that managed identity endpoint. Identity, which will happen automatically at the back. Identity. Okay. So, and if you know the principle of service principles, this is very similar to that, but slightly different, right? Way smoother to work with managed identities versus service principles. So for now, let's just go ahead and do it once. So we have to remember this name. Let's read it. Text Scalable Webinar ADF. And we have to go to Key Vault first. Let's do some configuration there. Then we will come back. And I'll go to my all resources. I should go to my resource group. And let's go to the Key Vault. over here. And now two things. First of all, let's create one secret, and we will not, so we don't have to hard code the SQL username and password over there, and we'll call it SQL key. And now I'll just put the password here. Okay, and that's good enough. Let's click on create. And now I just want to go to the access policy, and now I want to just say add, and I'm going to give it some higher level. So this is not limited access right now. I gave it like maximum access, but we can definitely go for the limited access as well. Now I'll click on the service principal, and the name which it was showing there, we have to search the name now. So that's the name which we have to give access on. So let's put it here. Okay, that's great. Let's select. So what really happened is, so that name which we just copied, that default name which got created is basically in Azure Active Directory, like, or you can say one token endpoint over there. And then that is the one which we are giving rights on the Key Vault in this point in time. So we are saying that, okay, add. Now that particular endpoint or that particular service principal is now having access on the Key Vault. And that is the one which we are going to use inside ADF to pull the data. So Key Vault is such a secure location that if you don't give access on the Key Vault, it really, we won't be able to pull any security keys or any connection strings from it. So we have done that. Now if we go back to Data Factory, we should be able to, let's say, click on test connection, and let's have a look at it. What does it say? Connection done. So it is able to talk to Key Vault now. Let's click on save, and secret name which I gave is SQL key. That's the same name which I gave over here. Let me confirm it. So SQL key over there, and then I think that's fine. Let's do a test connection. And okay, it's so now Data Factory, we don't have to hard code the passwords anymore. The passwords will be in Key Vault. Key Vault can be backed on HSM, which makes it very secure. And now I just click on apply, and at runtime it will pull the password from the Key Vault over there. Now it is saying that, let me read that. Oh, published immediately. Yeah. So we have to come back and finish it. So what it is saying is that you need to publish it first, then you can use it. That makes sense. So let's publish it first. So we have to do it. You can say, yeah, it's already there. Let me see if I can publish directly. Or we just had to click on this publish. It says that I just want to save that configuration. Then you can use it. That's what it is saying. And it should get published. Then we'll go back, we'll click it. Okay. Okay, publish done. Close it. Let's go back and let's complete that. So we were clicking on the edit, and what do we have to change? Key Vault, and let's go for the same. Now it is published, so it shows there, and SQL key is the name of the key. And let me just check the connection one more time. Okay, great. Apply. Done. So the keys, instead of hard coding the keys, we can put them inside the Key Vault, right? And that's how we do the integration. And one more thing which we can do, if we figure out more things where we have hard coded stuff, is if I go to my source location, you see the source location, sorry, sync location, which is the data lake. Data lake is also where we used the access key of data lake to connect. That was a default mechanism. We can make it more secure by putting that access key also inside the Key Vault. So if I go to open, and if I search for, sorry, not this, I just want to edit the connection over there, and let me see Key Vault, and we will find the, first of all, we will just quickly find the key we want to put there. So storage account, and we'll go for the data lake. We'll find the key from here, access key. So this once needs to be done in the environment, and then we don't have to do it again and again. So, and nobody will be able to, even any data engineer who is responsible for running these pipelines will not be able to understand the exact value of the key, because that is not exactly inside the data factory. So I'll save it over here. And one more thing which we can do is, instead of giving access on the entire key vault, we can also do that, okay, using that particular service principal, you can only read one key. Even that can further be configured. For now, I will go back and let me say key vault webinar, and the secret name is storage key. So storage key, and what is this name? That's the name I made over there, this name, storage key. So I don't hard code it anymore, and now I will just say test connection. So okay, done. Save it, and let's publish it for now. Okay, publish, done. So similarly, I can also do the same thing with Synapse, right? I hope you're getting the point. So what is the purpose of Key Vault? Key Vault is where all the keys will be kept, all the security keys, access keys, primary keys, any secrets which you have, secrets like the admin username and password of SQL, of Synapse, all the thing will be there. And there is one more integration which we can do. That integration means it is called as virtual, you can say VNet integration, meaning basically we can create one virtual network. Let me use a different color. And then we have one concept called as, we have two concepts. One is called as service endpoints, and one concept is called as private link. So if I use those concepts, basically the network will be applied on top of my solution. I can put it like that, or let me clarify that statement. I'll use a different space over here. So basically, if this is my virtual network, right, and I want private connection to any PaaS solution. PaaS solution will be like SQL, storage account, and so on and so forth. So we have one concept called as private link. This is private link. This is very similar to, if you know what is service endpoint, but this is cheaper than that. So this is expensive than that. Service endpoint will be cheaper than this, but this is very secure. Now the communication only happens from this VNet to that PaaS solution. So if we connect the data factory ADF also with, let's say with any virtual network, and you might be having resources over there, so they all can talk to each other internally using the private links which are there. So the platform as services will not be accessible over public IP addresses. They will be accessible over the private connection which is there. So by using the VNet integration, we can even make this solution even further way more secure than what we have created right now. So this is what I had for the demo, and we are about to come to the end of the time which we had. So let me have a quick overview of what we have talked about, and I'll just tell you a little more about Azure policy and how do we work with it. So we were able to create one ELT pipeline where we were able to extract data from SQL, load it into the staging location, do the transformation using data flow, where everything was backed on, you can say, which runs that on Spark cluster. And why are we doing all that? Because now we have that transform data which is in the stage, which is in the sync location, and now any other team who needs the data for, you can say, for their various purposes, for descriptive analytics or any predictive analytics, can use that the data which we have put over there. We can also provide other locations. It's not always have to be Synapse. We can have even less expensive locations on which we can provide data to data scientists, which can be like storage accounts. So all that discussion is for another webinar, which we are planning on machine learning very soon. So now there is one more topic which I had in the agenda, basically called as Azure policy. So let me just take another minute of your time to explain that concept. So this is my subscription, and this subscription is trusting the Active Directory right now, right? That's the Azure AD. So now if I want to, let's say we might be having hundreds and thousands of employees in the company, right? All the users are over there in the Active Directory. See, all of them are there like this. So if I want to have one mechanism by which I can restrict what is getting created, for example, I do not want deployment to be done. My project doesn't allow deployment to be done in, let's say, West US. So the project location is only East US. So I can create policies which are location based. I can create policies which are size based, SKU based. So for example, you do not want the virtual machines, very big virtual machines to get created, like maybe 256 GB RAM may be very big and maybe will be very expensive also. So we don't want that to be created. That may not be the requirement. So we can restrict it, that cannot be created, or only some of the virtual machines can be created. We can also go for type of resources. So maybe you are doing the solutioning for data platform, or you are doing the solutioning for any data integration, and you are looking for you're not looking for any other type of cluster, maybe Kubernetes over there. So you're saying that, okay, some type of resources will be blacklisted. So I can create policies on top of it. These policies are called as Azure policies, like that. Azure policy. So Azure policy will be able to, once we apply that, right? Imagine we have applied them. So Azure policies will be able to identify those resources which are already created and are not following the policy. If I want to deploy something which is GDPR compliant, if my solution is like that, we have one Azure policy which is having all the GDPR rules. So if you have any existing solution, you want to check out whether it is compliant or not, apply that policy. A policy will tell you the resources which are non compliant in that point in time. Secondly, I can also have Azure policy which will stop new deployment to be done. And practically in the company, when we do these, you can say infrastructure creation, we use ARM templates. So you may have a lot of ARM templates with you, and you may have many Azure policies with you and other configurations with you. So there is a very easier method called as blueprint creation. So we create blueprints, and these blueprints are internally combinations of various ARM templates and various other policies together. And so if you are doing any deployment, so you may have one blueprint for landing zone creation when the migration is done. So that blueprint can be used again and again, and internally it will be having multiple different templates, and they will deploy the entire infrastructure and will make sure everything is compliant. So that is one concept called as blueprint, which was part of the agenda. And this is what I had in the session. And this will prepare you for your 303 and 304 certification. And there is one, also put this contact details in the chat window, but you can find us on the sales email ID, and you can reach out to us over the contact number over there. So all